My name is Michael Wells. I'm an engineering technologist with Dell. And while my friend Sam was able to cover the idea of what the Apex Cloud platforms are, now I get to show you the meat, what they really are, which is exciting. So the first thing I'm going to do is start at the beginning, show you what a deployment looks like. So in this, let me jump out here. And for this one, I'm actually going to show you a side-by-side of the deployment process for both Azure and OpenShift, so that you can see that this isn't just a collection of products, right? The Apex Cloud platform really is a family. Right? So on the left, we have the deployment for Azure. On the right, we have the deployment for OpenShift. They're going through the same node discovery process. They're going through the same type of defining the node configuration settings, the node names and network settings. You're going to configure bonds and all of this, right? So we're collecting all of this information about how the cluster is going to be built out. Here we have network information, so the management network, the VLAN ID. We're going through and configuring the TPM for the nodes. In both cases, we're going to capture the rack name and the rack position. All this stuff is going to be accessible from inside the Cloud OS once the deployment's done.
So Michael, just to clarify, one of these is the setup process using Apex Cloud Management, and one is the setup process using OpenShift's deployment tool?
No. So this is, on the left side, we have the Apex Cloud Platform for Azure, for Microsoft Azure.
Okay.
On the right hand, we have the Apex Cloud Platform for Red Hat OpenShift. So they are both the Dell deployment automation, but for the different Cloud OS experiences.
And the outcome of this deployment is going to be?
A fully configured cluster.
Okay.
So one's going to be an OpenShift cluster. The other one's going to be a what?
Is going to be an Azure Stack HCI cluster.
Okay. That was the missing point. I was like, is it both OpenShift?
No. So the ACP for Azure is built on top of HCI OS. So Microsoft's HCI OS. Mm-hmm. So it's an Azure Stack HCI cluster, but it's a new level of Azure Stack HCI, right?
Okay.
So Microsoft announced the new level. So before you had validated nodes and integrated systems, and then they introduced the new Premier Partner tier. This is currently the only offering in that tier.
What's different in that tier? What's that tier?
It has to do with the level of integration and the level of collaboration with Microsoft.
Okay, so it's a partner program, not a different OS.
It's not a different operating system.
Okay.
It's a partner program, but it allows us to build capabilities that you can't do with an integrated system.
What are those capabilities you're building on top of that then?
So for example, with Windows Admin Center, we're not using the traditional extension framework within Windows Admin Center. We're actually using the Solution Builder extensions. So that allows us to do things workflow-wise within Windows Admin Center that you couldn't do with a traditional extension. Because the way the extension framework is built, it maintains that separation. So an extension kind of becomes an add-on. Right, this is using a different mechanism, so we can actually, and we'll see that in a little bit when I get to things like lifecycle management and integration, right? But what we're trying to drive home is this isn't, even though you're picking two different Cloud OSs, it's the same family of products. You should expect the same types of results and the same efficiencies from all of the products in that family.
Have you started working on the Tanzu side yet, or are you doing that?
It is being worked on. It is not GA yet, but it is planned for this year. Sam, I don't know if we can go into any more timeline than that, but are we working on the VMware version? So we announced the VMware version at Dell Tech World last year.
Yep.
But as far as time frame, I know we have it scheduled for this year. I don't know if I can be more specific.
And Azure is GA?
Yeah, that's correct. So
Okay.
Q2, Q3 timeframe.
Okay.
Thank you. Both the Apex Cloud Platform for Microsoft Azure and Apex Cloud Platform for Red Hat OpenShift are GA and available in the market today.
Okay.
So those are the ones that we're focusing on with this session.
So when you say a cloud OS, you're referring to one of those platforms.
Yes.
Okay, not an actual operating system on
The
on
cloud operating
computers.
experience,
Okay.
right? So in each case, it is an operating system. So in the case of ACP for Azure, it's HCI OS, but it's not just HCI OS. It's everything that's been built around that, right? When we talk about ACP for OpenShift, it is an operating system, right? It's OpenShift running on Red Hat Core OS, right? But it's what we're doing above and beyond that that makes this family of products unique.
Okay.
Right. So to show an example, the question was brought up, once the deployment's done, what do you have? So in the case of OpenShift, we have a fully configured OpenShift cluster. So it's based on our MC nodes, which everything in the Apex Cloud Platform family is based on these MC nodes. Running Red Hat Core OS, OpenShift for Kubernetes, their software-defined networking, and it's using Dell SDS storage as the backend storage, right? We connect to that through our container storage integration, our CSI, right? And you have the ability to run native containers on that, right? The secret sauce that Sam was talking about really has to do with that Cloud Platform Foundation software. That Cloud Platform Foundation software, in the case of OpenShift, is running in containers on top of OpenShift, right? So all of that is configured and done. So what you come out with on the other end is a fully configured OpenShift cluster with the CSI connected to the backend storage and the Apex Cloud Platform Foundation software, right? This is licensed using OpenShift Platform Plus. It's a specialized SKU of Platform Plus, but it does include entitlements for advanced cluster management, advanced cluster security, and Quay. So if you're familiar with OpenShift, you do have those entitlements to be able to do multi-cluster management and multi-cluster security. Right?
So that was ACM and what else?
ACS,
ACS.
advanced cluster security.
Is that extra?
No, it's all included.
That's included.
Yep, it's part of the license.
When you say entitled, why do you say entitled then?
So it's Red Hat charges a subscription for that.
Okay.
The OpenShift Platform Plus subscription that is included with this covers those features.
Okay.
Right? It has to do with their license tiering. So if you below that you have the OpenShift container platform that doesn't include those multi-cluster entitlements. OpenShift Platform Plus is the next level up that does. Right? The only thing unique about our SKU is it doesn't include ODF, which is because we're using Dell SDS as the storage. Right? And then, of course, that Cloud Platform Foundation software, which is really the amazing part, and I'm really excited to show you guys, is actually projected into the OpenShift web console. Right? So the deployment outcome for Azure, very similar. Right? The same MC nodes. The difference is you're using HCI OS, so it's that Azure Stack HCI layer. Storage space is direct, Hyper-V, and the Microsoft SDN stack. Right? The Apex Cloud Platform software is running inside of a Cloud Platform Manager VM on top of Hyper-V. Right? It's the same Cloud Platform Foundation software. Instead of running it in native containers, we're running it in containers inside the VM. Right? And of course, that extension projects that infrastructure management into Windows Admin Center. And of course, through Azure Arc, you have that connectivity with Azure for doing fleet level management, for doing Arc-enabled VMs, AKS hybrid, right? All of those features that make Azure Stack HCI a hybrid operating system.
So you're not replacing the management layer of the Azure Stack HCI. You're facilitating the deployment and lifecycle management of the hardware and the OS?
Yes. And then projecting our infrastructure management into that Cloud OS management experience.
So it can be aware of the status of the infrastructure components it's running on.
Right. The key is we're not creating a separate set of tooling that you need to go out to manage the infrastructure, right? To look at node status or health or alerts or anything like that. We are bringing all of that directly into the Cloud OS, right? So through the Windows Admin Center extension, through the OpenShift Web Console extension, we're bringing all of that management into that Cloud OS experience. So the people that are managing those clusters are using the same tool that they use to manage the cluster and the workloads on top of it to manage the underlying infrastructure as well.
So if I could draw a parallel as a crusty old VMware admin, the vSphere console allowed you to install plugins that you could use to manage and monitor the hardware behind and network behind your vSphere clusters.
Yes.
So this is in a similar vein. It's exposing that information and potentially allowing you to do some management functionality without leaving that management console.
So it's very much in line with what we built for VxRail through VxRail Manager,
Okay.
which kind of paved the way for a lot of what you're referring to.
Right.
Yep. So yes, it's that same thought process. We're just expanding it to a broader portfolio of products.
Okay. And the base assumption is that the hardware underneath is all Dell supplied hardware.
Yes.
Okay.
Yes, this has to be run on MC nodes.
MC nodes. Do you care about the networking?
So the networking is, so yes, we have a subset of approved networking options so when you say networking, we have a subset of approved NICs that we will allow in those nodes. As far as the networking, do we make you buy our switches or can you consume your own? You can consume your own. Right? We don't, as long as your switches support the features that the network needs, we're not going to say you have to buy Dell switching or you have to do this, right? We're agnostic there.
Okay.
So there's some prerequisites, obviously, in order to get the infrastructure ready for the deployment that we just saw.
Yes.
In terms of you need VLANs or networks or
That is correct.
whatever else ready. Yep.
Yes, and all of this is done through ProDeploy, so the Dell's ProDeploy. If we provide the switches, our ProDeploy will configure those switches as part of this deployment. If you provide the switches, then our ProDeploy engineers will work with the customer's networking team to make sure that everything's lined up correctly so that the way we configure the nodes is going to match with the way they've configured the switches.
Got it. And one more thing, would I then use, sorry if this was covered, would I also then use any of the other Dell management tooling for the kind of infrastructure monitoring and management, or is that all encapsulated in Apex now?
You could
I'm thinking old school open manage, that sort of stuff.
I understand completely. Yep. You absolutely could, but as you'll see, the need for that really isn't there.
Cool.
So if you have it and you want to use it, go ahead. These nodes have iDRACs in them. You can connect to the iDRACs. You can pull that information. What I would say is you're not going to use OpenManage to lifecycle. Right. So these have specialized lifecycle management workflows that are built into the Cloud Platform Foundation software that are aware of the Cloud OS that's there. And we'll talk more about that. So you won't use those features, but in terms of monitoring and alerting, you absolutely could.
Okay, thanks.
But you also have capabilities of, so for instance, the Azure piece that we're talking about here, we already have rules created for Azure Monitor that you can import in so that you can do alerting and monitoring right from Azure Monitor for all of your clusters across your fleet, right? So there's options. All right, and then of course you have the ability to run AKS hybrid on top of this as well. It's not a requirement, but you can.
So why did you choose to use Spaces Direct as opposed to PowerFlex on this one?
It's like you're reading ahead in my slides. So Storage Spaces Direct is because
Pay me later.
it's a yeah. We'll settle up off afterwards. Storage Spaces Direct is a requirement for Azure Stack HCI, right? So there's no way around that.
Okay.
But one of the things that we are adding, and this is a validated solution that will be available. We're in February now, so I can say next month. That will add support for the Dell SDS into the Apex Cloud Platform for Microsoft Azure, right? It's not going to remove the need for storage spaces direct within that cluster configuration, but it is going to give you an alternate place where you can store data so that you can use that data for virtual machines or, right? Which really will improve over time scalability, right? So we've already talked about the scale of what PowerFlex can do, right? Being able to scale to 512 storage nodes and being able to scale to 2048 compute nodes. Obviously, Azure Stack HCI today can only go to 16 nodes, and most clusters are far smaller than that. This gives you an alternate capability to be able to extend beyond those storage capacities. It also gives you the ability to scale storage independent from compute, which you don't have with the Azure Stack HCI today. For this next piece, we're going to jump into the hardware configurations. Is everybody excited? Yes, I see you rubbing your hands together. This is what everybody wanted.
Please give us more detail.
We can go as deep on this as you guys would like, until they bring out the hook and yank me off stage. So the MC nodes are based on PowerEdge 16G, right? They are a specialized configuration of PowerEdge. You cannot take any PowerEdge and turn it into an MC node, right? It has to be an MC node. Today, we offer two different options. The MC660 is a 1U 10-drive configuration, and the MC760 is a 2U 24-drive configuration. Right? In the case of compute, we have options for different CPU and memory. They're all Intel scalable 4th-generation processors. They are up to 4 terabytes of memory per node, which is a soft limit right now, and it's really not a technical limit. It's a supply chain thing. The 256 gig DIMMs are just not available, but that will go up. For storage, we have options for NVMe and SSD configurations, and then we have NVIDIA GPU support. So the 1U can handle the single width cards. The 2U can handle the single width and double width cards. All right, so right now that's primarily the NVIDIA A series. I know on the OpenShift side, we just recently added the H100, and we'll be adding some of the L series coming up here shortly. For people that are interested in AI and GPU workloads, we just launched a white paper November of last year that shows an implementation of OpenShift AI and a generative AI solution on top of the Apex Cloud Platform for Red Hat OpenShift. So we're actually using Llama 2 and RAG to build a chatbot that is trained against our technical documentation so that you can actually ask questions and it will reply and cite the pertinent sections of the relevant documents as part of the response. But expect to see more on that in the coming months. Right? AI is a huge topic right now. Any other questions? Anything else you guys want to know about the hardware?
Why do you need specific MC versions of PowerEdge servers? What's the difference?
The difference is the MC nodes have a subset of components. So this goes back to that continuously validated state. Right? We want to be very prescriptive as to which components we're going to utilize and what we're going to allow, where PowerEdge is wide open. Right? To be able to offer solution level support, we need to have control and be more selective as to which components we're going to do this. Right? So you saw the continuously validated state diagram. To keep that slide legible, we just showed a handful of line items. Right? That's a representation. Right? The actual list of what we're validating is significantly longer. Right? We're not just doing BIOS, right? We're going firmware on the NICs, firmware on the motherboard. We're doing the iDRAC software. We're going firmware all the way down to the disk level, right? So it's a lot of things that need to be validated. So for that, we need to make sure that we have a manageable list of components that make sense for what we're building. And that's the reason.
So that also, I mean, you pretty much exclude existing implementations from the solution with that approach. Is that something on the roadmap though, where customers can bring their own existing servers?
Not at this time, right? So this solution is intended to be the common building blocks. That's really the heart of the Apex Cloud Platform, what Sam was talking about at the beginning, right? And the fact that we've made these common across the different products within the family, to open it up and say any PowerEdge server can become this, it's too complicated to manage that, right? As it is, we're already managing all of the quirks across the different cloud OSs.
Sure.
Right.
Okay, that makes sense.
Yeah, if I can add to that, I would say that there's a couple of reasons to do it. It's something that we did with VxRail as well, where when we have predictable hardware inside of a platform, it makes that automation that much easier. So rolling out firmware updates, when we know every disk that could possibly be in there, we know what to include in the bundle. If the bundle needs to be, broad enough to encompass everything that's ever been sold in the PowerEdge, it would be unwieldy and never applicable.
No, and I get the engineering effort of trying to maintain that compatibility.
Sure.
The other side of this is meet where the customer is. A lot of customers just have a ton of hardware
Certainly.
already. Right, so it's a balance of where do you meet your customer. And I totally get for a fairly new solution, you're going to go with standardized packages like this. But as the solution matures, you're going to need to go where the customer is.
Yeah, and I would suggest that as for the customers who maybe already have gear on the floor, that's where we can leverage some of the cloud-based storage that we saw earlier, and it would also mean that customers can pick up some of our storage offerings like PowerFlex. So we do want to be able to provide as much as we can for customers, but in the automated, simplified, engineered solution that is Apex Cloud Platform, yeah, we're very prescriptive about the nodes.
And to your point, so we do have for the OpenShift and for the upcoming VMware version, the ability to support PowerFlex as the storage, as opposed to what we refer to as Dell SDS or the Apex Cloud Platform storage nodes, right? And if you're using PowerFlex as your storage, you can connect to PowerFlex using anything that PowerFlex supports. So any operating system that you can configure that we build an SDC for, which includes Windows, most of your Linux distributions. I think we even have some mainframe support for SDCs. We also have support for NVMe over TCP. So if you have solutions, so we can connect bare metal, we can connect hypervisors, we can connect a lot of different things up to PowerFlex. So that would give you the ability to start to consume that storage. And then over time, as that hardware ages out and gets refreshed, then you could bring in the Apex Cloud Platform compute connected to that same PowerFlex storage backend to be able to replace that compute and modernize those applications. Right?
So you mentioned Red Hat OpenShift and VMware.
Mm-hmm.
Is it only those two, or what happens if somebody says SUSE Rancher? Would you just...
So we don't have an Apex Cloud Platform for SUSE at this stage, right? So what we announced last year were Microsoft Azure, Red Hat OpenShift, and VMware, right? So those are what we have, right? Can we add more over time? Possibly. I mean, it's meant to be an extensible family, right? We're building out the foundation. We could onboard additional partners, but what we have today, what we talk about, are those three.
Okay. So it's an opinionated infrastructure deployment.
Yes. And you'll see when we get into the actual management console, you'll see why that is.
Okay.
Right.
Thank you.
Any other questions related to the hardware? All right. And so now let's go into the management experience. This is my favorite part. So the core of this is being able to get that consistent hybrid management experience, right? We're not pushing you into OEM-specific tooling. You're not even leaving the interface that you would use to manage the cluster on a daily basis, right? So this example, we're showing you on the left the OpenShift web console. And we're actually in the Dell Apex Cloud Platform menu within the OpenShift web console looking at a list of the nodes, right? So I can glance at the node information right from the web console. And then on the right-hand side, the fleet management at scale for OpenShift is, of course, advanced cluster management. Very similar when we look at the Azure side of things, right? So your local cluster management is going to be through Windows Admin Center, right? So we've built that extension for Windows Admin Center where you can see those nodes and that infrastructure information right within Windows Admin Center, right? And then again, for your fleet management at scale, you're going to use your Azure Management and Governance Services. But the idea is you're using consistent tooling for that Cloud OS. All right, so let's jump into the OpenShift Cloud Platform. So what we have is Red Hat OpenShift, right? It's a normal 4.13 deployment. This happens to be on an Apex Cloud Platform for OpenShift cluster. So you'll see this new menu item on the left-hand side, Dell Apex Cloud Platform.
Can I have a question?
Yes.
Do you support a hyper cluster of OpenShift?
You're asking about HyperShift.
HyperShift, yeah. Yeah.
It is on the roadmap. It is in the works. We definitely recognize the value of, so it was HyperShift while it was in tech preview.
Yeah.
Now that it's launched in 4.14, it's officially referred to as hosted control planes.
Exactly.
But yes, we are absolutely working on support for that.
So you work to support that on the native deployment on your hardware or as well on Azure Stack?
So that's not going to be on the Azure side of things. That would be supported on the Apex Cloud Platform for Red Hat OpenShift.
Gotcha. Thank you.
Because really, we feel that ACP for OpenShift makes the perfect host cluster, right? So if you're going to host multiple control planes on that cluster, why not host it on a bare metal cluster that you can do that infrastructure management right
but
from?
It's going to be inconsistent with the stack in the Azure stack. So there are going to be different. Potentially, you could land with the two different configurations. So you will have a hyper cluster on your traditional infrastructure, and then you will have a little different infrastructure on Azure Stack. A little bit.
Not really.
Okay.
So, let's take this offline
Sure.
because I would love to have this conversation, but I think it's going to be a little bit too much of a tangent. All right, so what we have is the Apex Cloud Platform menu. So here I can see cluster information. I can see the status, if there's updates available, CPU, memory usage, things like that. I can see the Red Hat version and the cluster version. I can go into inventory. And I can see the nodes within the cluster, right? If I dive into one of these nodes, I can see the front of the cluster, the front of the node. I can view overview information, including, I had mentioned that rack position, the location information is accessible from in here. The iDRAC IP address is right here if I needed to get to the iDRAC for some reason. I can see alerts. The boot devices, so in the case of ACP for OpenShift, we don't do disks in the nodes, in the compute nodes. We use BOS. So the core OS is actually running on BOS drives inside the node. And you can see the device status for those drives. All right. Now, I can also look at the back of the node. That includes drilling into each individual component within that server. So I can see health, I can see firmware information. I can look at the status of power supplies. I can even drill into individual NIC ports within a multi-port NIC, right? I can look at MAC addresses. I can see the link speed, the link status, is that connection up or not? If I had GPUs in these nodes, I'd be able to see the GPUs in here as well. So all of this information about the infrastructure is available to me right here in the OpenShift Web Console.
Can I perform actions on that hardware, or is this purely informational?
So right now, the only action is to blink the LED. We do, within the node list, you have the ability.
But that's super useful.
No,
Which server is that? Make it blink. Got it.
Yep,
No, I'm just like,
absolutely valuable.
I understand it's really useful. I'm just like, okay, where did you I'm just
Well,
starting there?
So we do also have the ability, and I'll touch on this in a little bit, to add worker node right from within here. So I can expand the cluster. I can also remove worker nodes from the cluster right from within this console.
Okay, so if you need to put one in maintenance mode to do something, or you're just ejecting it from the cluster because it's being retired, you can.
Right. So most of that is going to be through OpenShift mechanisms, not through Dell mechanisms.
Right. The actual removal from OpenShift can do, but then.
Well, so as we do remove node, it's going to remove it from the OpenShift cluster.
Okay.
But it's also going to take the extra step of reimaging that node back to factory.
Oh, okay.
So that node is now in a state where it can be either retired or it can be added into another cluster.
Are you also using Ansible to do that as well, or is it just pure OpenShift?
So we are using our automation. It's the Cloud Platform Foundation software that's handling the workflow, and it's wrapping OpenShift API calls and mechanisms. Right. That's part of that Cloud Platform Foundation software, right? It's the deployment automation, it's the lifecycle management, the day two operations, and also the LCM. But I did have a question come up once of, well, if I needed to disable a NIC, could I do that from here? And the answer for that with OpenShift is you wouldn't do that through the hardware, you would do that through OpenShift, right? So it's so as we look at updates, you'll see we have the ability to pull updates from the internet. This requires that you configure a Dell support account. And then we also have the ability, what we refer to as local updates. So we can deploy this in a disconnected environment. You could point to the update bundle that you download from Dell support, upload the files, and then run the update that way. Security, this one I really like. This gives us the ability to manage the certificates. The Apex Cloud Platform API Gateway, which is the Dell one, but also the OpenShift Ingress and OpenShift API certificates can be managed this way as well. Right? If you stick with self-signed, they'll auto-update. But if you move to an enterprise certificate authority, then you'll want to manage those. And management is just as easy as clicking Update Certificate, pasting in the information, and saving. And it'll rotate those certs for you. Within the settings, we can support network proxies. These can be HTTP, SOCKS 4, or SOCKS 5. This is where you would configure the support account. It's just a matter of a username and password that has support access. Connectivity. This actually ties back to our dial home capabilities, but also provides integration into Cloud IQ, right? So you can actually step through this process that's going to enable dial home for any hardware-related alerts, enables secure remote support connectivity, as well as Cloud IQ integration. You can connect the Cloud IQ integration today. The information will be available in Cloud IQ in a future release. Right, so we're waiting on a Cloud IQ update. And then you'll be able to see inventory information in there, and then eventually telemetry data. Last piece is support. So you can create a support request. If you've configured that support access, you can search the knowledge base right from within the OpenShift Web Console. And then we have the ability to create log bundles. So I can go through, create a log bundle, and I can collect which information do I want to grab. and be able to create that. One other piece I want to touch on before I head on to the Azure side. Notice that we have the ability to view alerts and view performance. When I click on view, notice I'm not going to a Dell page, right? I'm going into OpenShift alerting, right? All of our hardware alerts are flowing directly into OpenShift alerting, because if customers have already put in integration, monitoring, and notifications based on OpenShift alerting, we want to be able to leverage that. We don't want you to have another view that you've got to go to for the hardware, right? So it all flows in together.
What about observability, platform integration there? Things like Splunk, Dynatrace, Datadog.
So if you're pulling from OpenShift alerting already, then it's already going to be in there. So if you've already integrated OpenShift alerting with those other tools, those external tools, then you're going to inherit that, right? So our alerts are going to flow into that same system.
But the integration you're doing here, so if I've got to go via OpenShift to get to Splunk, for instance.
No, I'm saying if you've connected OpenShift alerting to an external system where those alerts are flowing from OpenShift to an external system, our alerts are going to flow through that same channel.
So I've got to go to my Splunk UI to look at my...
If that's the way you've configured it, yes.
There's no integration in the same way you've done with OpenShift. There's no kind of, I can't look at it all in one pane of glass. I've got to get out of this for my Dell and OpenShift, and I've got to go over here into my Splunk console.
The point of this is we've put the alerts in the same place your OpenShift alerts are going to be. So if you've done something to connect your OpenShift alerts to some other system, whether that be a monitoring system, an analysis system, right? If you've done that work, we're going to flow through those same channels. So you're going to go to the same alert view for our stuff as you would for any other OpenShift alerts.
Yeah, there's just not you haven't done a single pane of glass integration of something like a Splunk or a data. I've got to actually go out.
No, because if we built that integration, then it's just going to be for our stuff.
Yeah.
Right, we don't want to do that. We want to put it into OpenShift, and then you integrate it OpenShift however you want to.
Understand.
Right. Same thing with performance. We're directing you right into the OpenShift dashboards. So here we have an Apex Cloud Platform for Microsoft Azure. So as you can see, we're in Windows Admin Center on the Apex Cloud Platform view. Right. So we can go look at the physical view, so we can see the list of nodes. We can see the health information at a glance of those nodes. We can drill into a specific node and see more detailed information, that front view, that back view of the node. All right, we can click on an individual item and see the details about that component. All right, here's the back view. And again, I can drill into a specific NIC port. Are you starting to see that consistency across the platforms, even though it's implemented in a completely different cloud operating system, a cloud operating experience? That consistency across the Cloud Platform Foundation software and what we're enabling through that cloud-specific OS.
I suppose the fundamental question for me is, why would you do this rather than Azure Stack on-prem? Is it you like Dell hardware? Because the control plane, I mean, you just mentioned the Microsoft Azure. I'm just trying to, what's the decision process that I would go through as a,
so this
as
is
a
implementing,
buyer to go, I'll do this versus do that?
This is implementing Azure Stack. This is Azure Stack HCI.
So I'm like, Azure Stack's hardware in with their control plane versus your hardware.
Microsoft doesn't. Microsoft has very limited hardware for what they offer for Azure Stack HCI, and Azure Stack Hub is primarily OEM, right? So most of your Azure Stack HCI implementations are OEM implementations, right? So you need to pick an OEM vendor to go with to implement Azure Stack HCI.
Yeah.
The question is, which OEM vendor do you pick, right? And what we've built out is integration that nobody else has.
So if someone were to select Dell or be an existing Dell customer, at this point in time, would this be the path that you would probably send them down to deploy their Azure Stack, for example?
So if they were an existing Dell customer and they wanted to implement Azure Stack HCI, this is absolutely the path that I would recommend. Same thing for OpenShift. If they're an OpenShift customer, ACP for OpenShift is exactly how I would recommend implementing it.
Yep.
Right? Because anything else isn't going to be full solution level support, right? With this, we are providing full stack support, full stack lifecycle management, right? Anything else is going to involve some level of DIY.
You mentioned OpenShift and Azure Stack HCI. Was there other cloud OSs that are coming in the future, or is it just going to be those two for the foreseeable future?
So we have VMware coming.
Okay.
Those are the only ones I can speak to today.
When you say VMware, we're talking like VCF, or more just like
vCenter.
vCenter with vSAN and NSX bundled?
It would not be vSAN. It would be Dell SDS storage.
Okay. All right. So it'd be SDS storage and then NSX if you want it, I guess.
I'm not sure. I'm getting a nod.
Can you still buy it that way from VMware? You can't.
You gotta buy it all.
Well, you can buy. You can buy everything. You just won't be using everything.
Right.
Well, yeah, good point.
Yeah,
You
so
buy VCF and then you just not use some of the things.
Well, you don't have to buy VCF. You can get vSphere,
vSphere Foundation, VVF,
VVF,
right?
va.
If you need vSphere, you got to buy one of those.
Mhm.
If you want
Okay.
NSX, you need VCF. If it's going to be integrated with Apex Cloud Platform, who knows yet? TBD, right?
So we have the ability to do a compliance check. What this is doing is it's going through and checking your compliance against that continuously validated state, just ensuring that everything, it hasn't updated yet, just ensuring that everything is in line so you can report on that compliance and know if anything needs remediation. All right, we can see alerting, the server information, so another view of the server inventory that's not the physical view. So you can see more detail like CPU and memory information. All right, we can see the storage information. This is S2D today. Updates, so we can see if there's any available updates. Security, so with the Azure side, we have the concept of what's called infrastructure lock, where you can prevent changes to important settings within BIOS and iDRAC. Those settings can't be changed while the infrastructure lock is on. We also have support for secured core server. And then, of course, very similar, the support integration, the knowledge base, being able to create a support request, being able to show the latest configuration, and then, again, log generation. So being able to create a log bundle. So I hope you are able to see what we're getting at, the consistency between the different platforms, right? And how we've taken that infrastructure capability and elevated into what the cluster admins are using to manage the cluster on a day-to-day basis. All right, lifecycle management. So let's jump back into the next set of demos. All right, so this particular demo, we're going to step through the lifecycle management for Red Hat OpenShift. All right, so what we've done, because you need support portal access to be able to check for online updates if you want to update from the internet. So you can see configuring the support access is just a matter of configuring your username and password. Once you've done that, it'll be able to go out to the Dell support site and check for available updates. There aren't any at this time, so we're going to use the local update process. We're going to grab this update bundle. So it's a collection of files. We're then going to upload those files. Of course, this has been sped up because nobody likes to watch a progress bar.
Is it 100x faster?
There are different points of this sped up at
Now.
different rates. So, but the idea is, once the bundles are uploaded, we're going to decompress them and go through validation, make sure everything's good. Next is the pre-check process. Right, so what we're going to do is check the cluster health to make sure that the cluster is in a state where we even want to attempt to update it. Right, if something's wrong, we're not going to proceed with the update until it's remediated. Right, so we've passed all the pre-check. Now we're doing the review. So it's gone through, it's identified all of the versions of the appropriate software that's on the cluster and telling us what's going to be updated within this particular update bundle. So you can see there's the Cloud Foundation software and OpenShift are going to be updated during this process. So now we're kicking off the update. You can tell it's telling you how much time it's expecting that update to take. And then it's giving you detail as it runs through that update process. So what are we doing here? We are updating all of the hardware, so BIOS, firmware, drivers. We're updating the OpenShift software, which includes the underlying core OS. We're updating the CSI, and we're updating the Apex Cloud Platform Foundation software. All of that's being done in a single update workflow, right? We can get this done a lot faster because it's done as a single workflow. We can control the sequencing of how that update takes place, right? That means we can do things like firmware updates. We can stage to all of the nodes in parallel, then move on. And once the OpenShift update goes through its process and reboots the node, those updates will apply to those nodes as part of that reboot process, right? So we can do things in the most efficient way possible to reduce the amount of time it takes and the amount of reboots you're going to have to go through for the cluster. So that was OpenShift. Now we're going to go into Azure. So in this particular case, going to do the same thing. We're going to configure a support account. Again, just a username and password. All right, so you can see that that support portal access has been enabled. Now we can see that on the dashboard that there's one update available. So if we go back to updates, you'll see that there's an update available now. This view is going to show you both Microsoft and Dell updates. Right, so you'll be able to see all of this in a single view, and you'll be able to apply them together. All right. So now what we're going to do is we're going to go ahead and apply the update. It's going to run through a very similar process where it's going to do an analysis of everything that's on the system, that compliance check. And this is a very extensive list, right? It's all of the individual components. As you can see, it's checking a long list of items within each of those nodes to make sure everything is exactly the way it should be. As a result of that, it's then going to say, right here, all right, so we've run the pre-check now where it's checking the health of the cluster. So everything is healthy. We're okay to continue. So we'll do next. Now you're going to get this warning. Servers in lockdown mode will temporarily, we're going to remove that lockdown mode during the update and automatically turn it back on afterwards. I had mentioned that this is a mechanism that protects the iDRAC and BIOS certain changes. So we need to disable that during the update process, but once we're done, we're going to automatically turn it back on. Right, and again, it's going to go through and update the cluster. We'll show in a moment here. This is actually going through Similar to the way the other one was, it's doing a rolling update. So one node at a time. It's going to put the node in maintenance mode, which will drain all the roles from it, update the node, bring it back up, back in, move on to the next node in the cluster. So across the Apex Cloud Platform family, those updates are non-disruptive, right? And you can see the list of everything that it did as part of that process. All right, so we've run through lifecycle management for both the OpenShift and the Microsoft Azure products. Again, all this is done completely from within that CloudOS experience, full stack updates. All right, next piece we're going to talk about is scalability, cluster expansion. All right, from here, let's jump back into the demo. All right, and this is, we'll start with the OpenShift cluster. All right, so here we are in the Apex Cloud Platform menu. We're on the inventory tab, so we're going to hit actions and add worker node. All right, what it's doing now is it's going through and searching for any new nodes. Any nodes that it finds, it's going to run a compatibility check against those nodes. Right, we want to make sure that those nodes are compatible with the existing cluster, because we're not going to allow you to add a node that isn't what we would consider compatible. Right? So once it's said, all right, this is a good node, we can select it, start to fill in the information. We have a couple modes here. We can do autocomplete, or you can select advanced, where you specify the values individually. Right? There is information that we've already pulled in from the existing cluster. So for example, the network information, the subnet mask, VLAN ID, all that's been pulled in already. So we're defining the name of the new node. We're going to give the IP address of the new node. And we're going to set the TPM passphrase for that node. All right, here we're going to set the location information, the rack name and rack position. And we're going to go into the NIC settings. So this is going to define those bonds. They're already pre-configured, matching what the cluster had already set up. Then we're going to go into the network settings and define the IP addresses for those. Right. From there, we're going to go into validation. And notice the VLANs are already pre-populated to match the existing nodes. Right, it's going to check and make sure everything's good with that configuration. And then from here, we can kick off the add node process. All right. And there is a little message, a little banner that's going to pop up here that says adding node into the cluster. Right, and from here, it's going through the process of deploying everything to that node, adding it into the OpenShift cluster, configuring the Cloud Platform Foundation software appropriately. Now we'll jump into the last one for the ACP for Azure solution. I'm going to skip ahead here because there's some other considerations related to ACP for Azure depending on what network model you're using. whether you're using the scalable, switchless, or two-node back-to-back configuration. Right? But the same type of process, what we're going to do is add the node. It's going to go through and do that same discovery of new nodes. So our current cluster size is 2 servers. It's going to find that there's a new node that's available, and it's going to run that compatibility check. Right? So it already says, all right, this node's compatible. Right, now we're going to go through the settings for that server. Very similar process, right? The IP address, in this case it's Windows, so we're setting an administrator password, the rack position information. The network's already pre-populated. This is going to match what the cluster's already configured for. And it's going to go through the validation and then the add server process. Okay. While this is running through, any questions? So really what we've done here with this product family is something that hasn't been done before in terms of bringing that infrastructure management directly into the CloudOS experience. And we're enabling that for different cloud operating models to give customers the choice as to which one or which ones they choose to run in their environment. I've left everybody speechless.
Good job.
So one of the things you kind of left out for the group here is that the Apex cloud platform for Red Hat OpenShift is installed on bare metal.
Yes, both of these are bare metal
If
solutions.
any of you guys have done anything with OpenShift on bare metal, it's a bear.
It's a bare metal.
Bare metal. Thank
Boom,
you.
boom.
Very good.
Grr.
It's a bear. It's a real bear, and that they have streamlined this to put it on bare metal. We had worked on in our lab doing it, and it was, I know I sound like I'm promoting these guys, but we've got a lab, and we did trying to install Red Hat OpenShift on bare metal, and we gave up, even with support from Red Hat. They said, oh, we don't do it that way. We always put on VMs.
Yes, the vast majority of OpenShift deployments on-prem are on top of a hypervisor today.
Yes.
And there's a couple reasons for that. Number one, you have the simplicity of deployment. It's much easier. The other piece is there is very little hardware integration inside of OpenShift.
Mm-hmm.
So lifecycle management of the hardware has to be separate from lifecycle management of the OpenShift software. Right? There's no mechanism to do the two together until now. Right? So being able to create that separation between the two means you could update the hardware underneath without affecting the VMs running on top of it. So that you've decoupled, right? But by doing this solution, we've automated all of that for you, and we've put in place that entire lifecycle management of both OpenShift and the hardware together so that you don't have to do that. And the benefit is OpenShift on bare metal runs faster, right? You don't have a hypervisor in between, right? You don't have CPU scheduling and all of the other pieces. You don't have the licensing requirements for a hypervisor, right? You don't have the attack surface of a hypervisor. You don't have another layer of administration in the way between OpenShift and the infrastructure, right? So it vastly simplifies that process, gives you access as a developer to more of that hardware that OpenShift is running on, right? But it simplifies the process of using that significantly. And it opens up scenarios like what was being discussed with hosted control plane, where you could now better leverage that hardware to host additional control planes and even host through OpenShift virtualization virtual machines directly into OpenShift, right? A lot of people go, well, why would I use OpenShift virtualization instead of a hypervisor? Well, one of the aspects is with OpenShift virtualization, it's using KubeVirt. It's upstream KubeVirt, right? So I'm running KVM in pods. So I'm running that virtual machine inside of a pod. That means the workload on that VM can take advantage of pod-to-pod networking, right? If I was doing a VM outside of OpenShift, if I'm communicating with any workloads running on OpenShift, I'm going through that ingress. All that traffic has to be routed through the ingress controller. If I'm initiating that traffic from another pod on OpenShift, I get pod-to-pod networking. I'm not being routed through that ingress controller. I don't have to create an external route to expose that service outside of the cluster so the VM outside the cluster can consume it. Right? So there's a lot of benefits to being able to run those workloads directly inside of OpenShift.